Okay, we're back for part 2. Sorry about that. My iPad is low on battery, as I mentioned, and it did that thing where the low battery notification pops up and my screen froze. So anyway, we're back. I like mu1 equals mu2, but you can choose to do mu1 minus mu2 equals 0. That's fine. And we are looking to test that against an alternative hypothesis. In this case, we would say mu1 is greater than mu2 because we're hoping that the people that are taking calcium are going to have a greater change in their blood pressure. All right, where mu1 equals the true mean systolic blood pressure for the people taking calcium, and mu2 is for the people taking a placebo. So I'm going to start talking a little bit more quickly now. Ready? Here we go. Plan. We will conduct a 2-sample t-test for means if conditions are met. Conditions are the same as we just talked about, so I'm going to talk through them real quickly. So here come my conditions. My conditions are, they are both, they are randomly assigned, so it's not a sample, but there was random assignment, so that's good. And because there's not a sample, we don't have to talk about the 10% condition. To get the approximately normal condition, you're going to want to use your graphing calculator and get box plots of each distribution, so 2 separate box plots. And then in your plan, you are going to write up that box plots show no strong skewness or outliers and include a little sketch. All right, I'm skipping to do. So you are going to find a t-value, and you're going to do that by subtracting the means that you get up here, these little x bar 1 and 2, divided by the square root of the standard deviation squared over n1 and the standard deviation of the second distribution squared over n2. In this case, here's what it looks like. So again, this sort of boils down to 1.604. So we're looking at degrees of freedom 9 here because our smaller distribution has 10 things in it, and our degrees of freedom is n minus 1. So you're going to go to your table and you will find that your p-value is between 0.05 and 0.10. Now, we weren't given an alpha level, so I guess we're going to default to 5, and we are going to say, with a p-value between 0.05 and 0.10 at an alpha level of 0.05, we fail to reject the null hypothesis. There is not convincing evidence that the calcium supplement is helping to lower systolic blood pressure. Now, as you can imagine, the calculator does both of these tests for you. And so if you take your calculator and choose statistics and then tests, you should be able to find something called a 2-sample t-test. And if you call that up, if you already have your data in the calculator, it gives you a choice of data or statistics, but you have the data in your calculator, so you can make that choice, and then it will automatically default on your screen to L1 and L2. If your data is somewhere else, change that, and you can give this a try. And from the calculator, I think it was something like 0.06 or something like that. But that's nice because you can get a check to make sure that it falls within the range that we found previously. Similarly, if you look in the test area, you should be able to find a 2 sample t interval, and sort of same thing. It'll prompt you. In this case, if you wanted to try this one, we don't have the data, we just have the statistics, so that's the choice you make, and then you'll enter all of these little guys, and it should give you something very, very close to the interval we came up with. It will tell you the degrees of freedom is something different than what we used, but that's nothing to worry about. The calculator has some sort of fancy formula or something it's doing to calculate the degrees of freedom. All right, so that was quick. Also, I just want to point out that we have this nice little reference sheet, and this has the formulas for both proportions and means on it. And so that is sort of a wrap for Chapter 10.